All right, hello everyone, and welcome to Vertical Location, the holy grail for first responders. We're really happy to have everybody joining us today. Today's session is going to be jam-packed with some great insights and information on exciting new capabilities, so we're really eager to get right into it. Here's a quick agenda for today's session. We're starting off with Charles Werner, who will talk about why first responders need vertical location. Then we'll do a short Q&A for his session. Then we'll hear from Chris Gates, who will talk about how NextNav is bringing vertical location to life. And then finally, last but not least, Deepak Joseph will join us for a discussion about the specifics of how vertical location can be integrated into public safety apps. And then finally, we'll do another Q&A where we'll answer any other questions you might have. And before we dive in, I just wanted to talk through a couple of quick logistical notes. We'll be making the recording of this session available on our website once we're done, and we're going to send it around by email to all participants as well. For those two Q&A sessions, we'll have the chat open during the whole session, so please feel free to ask questions as we go along, and we'll answer those when we get to the Q&A sections. And now, without further ado, I'm very pleased to introduce Chief Charles Werner. Charles was a firefighter for 37 years in Charlottesville, Virginia, and the last 10 of those as fire chief. He's held many senior advisory roles at the state and national level, and now works as a director with the Drone Responders Public Safety Alliance. Charles is well known in the first responder community as a thought leader, and we're very pleased to have him speak today about why first responders need vertical location. So Charles, over to you.
Ben, thanks. It's great to be here with everybody to share what I see as one of the most important technological advances for public safety, especially the fire service. If we want to go into the slides. So why first responders need location, particularly the Z-axis is what we're talking about. And the Z-axis is that elevation piece that we've been missing for so many years. But incident commanders need to be able to find first responders in multi-story buildings and complex urban environments, especially when they are in trouble. And the current location services don't offer reliable, accurate altitude measurements. But I will tell you, this is more than a theory. This is more than just a concept. I have actually had the opportunity to go out and see in San Jose where this is set up and stand on a floor level and move up and down through the floor levels and see where I am at every moment, even to one point that I could tell what room I was standing outside of. As you said in the beginning, this is the holy grail for public safety. Up until now, we've had no real way to know where a firefighter is down in these very huge buildings during a fire situation where conditions can be very bad. So why is it so important? Because our first responder safety is the #1 priority for all incident commanders. And I can tell you, the nightmare for every incident commander is to hear the word Mayday, firefighter down. And that immediately puts us in an entirely different mode. The other part is operational effectiveness, means that we can see the entire scene at a glance without the need to constantly check in by radio. This means communications are reduced and there's a lot less confusion as far as verbal communications go. But I can visually see the movement, not only of one, but if I need to, I can see the movement of all those firefighters at the same time. That gives me an idea of the disbursement of our personnel. And if something goes wrong, I can quickly get a glance at who may be impacted by that particular event. And the third piece, which is kind of exciting down the road, is that as this extends out to the callers who call in, especially from these urban environments, in high-rise buildings, one of the biggest things, or the biggest challenges we have, is locating them. This gives us a way that we can actually see in the future where the caller is located, where the responder is as they're moving to get to that person of aid and get there more quickly. Next slide. So this is a little bit about what first responders told NIST when they were asked about the vertical location. And they say, from a police officer standpoint, all we have is a pastel colored background with a square outline of a potential building that may or may not be accurate. So you have kind of a blank slate. From the fire commander, from an accountability perspective, somebody gets turned around in a building and they're lost. I'd like to be able to say they're right there, and we don't have that now. When this changes, we will actually be able to see what other resources are most closely to those people and be able to direct them accordingly. And from the EMT, the buildings downtown are an entire block. There are 3 levels before you get to street level. We have to walk back and forth to find out where to go. Again, that's that point of being able to see both the caller and the responder. And then lost my screen here. And then the last part is I've got hundreds of high-rise buildings in my district. I go to high-rises all the time. I don't know how many floors are there from a firefighter perspective. Now we're starting to see the building, the floor plans, the floor levels. We have a much better orientation in the building. Next slide. Making sense in a multi-story. The question is, where's Wanda? And Wanda, a firefighter, just arrived at the scene of a structure fire on the 15th floor in the Salesforce Tower. Can the incident commander find where she is? And here we go. This gives you a visual of where the person is located. Today's technology delivers latitude and longitude and creates a point on the map and associates that with the address location. The incident commander knows that Wanda is in the Salesforce Tower, but doesn't know where she is in respect from an XYZ component. Next slide. With the vertical location, now we have the defined altitude, floor, or story, which completes the picture, X, Y, and Z. And the incident commander knows that Wanda is on the 15th floor, the southeast side of the building. And as we pull in more information, we'll actually be able to see more specifics to that. Next slide. First responder need vertical location. How can app developers deliver? Next slide. So what we've talked about now is what this means to each one of these disciplines in public safety. What we need from you as developers is to create an app that is easy to use, that is intuitive, and that gives us the information that we can actually differentiate by what information we need at what time. Because what we don't need is to be overwhelmed with information. The incident commander of any of these situations needs to know what information they need when they need it, and only that information that they're requesting. So the ability to be able to see it all, or to narrow it down just to see a little piece of the pie. And I'll stop with that.
Awesome, thanks, Charles. There's some great insights from someone who's really been on the front lines of all this and can actually see what a lot of those first responders need. I'll just start off the questions with one. Just what does this vertical location technology mean to you? Like, how does it matter to you personally in your experience as a firefighter and fire chief?
Well, fortunately, in my 10 years as fire chief, I never had the experience of a firefighter down. So I was one of the lucky fire chiefs. But when I hear the stories, or I hear the audio from a fire scene that occurs, or listen to the commanders when they're having that communication, it is the most terrifying moment that you'll have, because you know that minutes make the difference whether a firefighter lives or dies. So having that X, Y, and Z, that vertical location, now tells me on a regular basis where these firefighters are located, so I can monitor the activity. And again, I guess the other part for the developers is also to putting into some of the features that would have, if there's no movement for a certain period of time, that it gives an alert. So it shows that a firefighter is not moving. And maybe even the breadcrumbs that show from the path that a firefighter's made over the certain path. For me to be able to look and direct the other resources to that would be phenomenal. And it means, again, I can quickly direct people as opposed to otherwise, we're literally going into dark, almost zero visibility smoke with no idea where the firefighter is located. So think of that for a minute. Now I can direct the firefighters that can go and use their other tools like thermal image cameras and other things as they get into those environments to find the firefighter more quickly. So it is the most important thing to a fire chief and an incident commander during those situations.
Right, so it's not actually just about the location itself, but the location can make a lot of the other tools that you're using better, in a sense.
Well, the location of both the firefighter down and the other firefighters that are in proximity is a game changer, because now I can also see who is closest to help, and that's time, minutes, life or death.
Yeah, absolutely. And feel free to add any other questions you have in the chat. Meanwhile, I'll ask Charles another question here. How long have you been waiting for this technology? And what do you think the reception will be when first responders actually start to use it out in the field?
Well, I've been involved with the fire service for 47 years. We've been waiting for 47 years in my time. We've gone through different iterations. We've got the personal alerting safety systems that we use, the PASS devices, but they're just audible, and you hear if a firefighter goes into an audible mode, hopefully, which is kind of difficult to locate inside a building where you're disoriented, even as a firefighter who's not disoriented, trying to locate that beacon even with a light. So it's been 47 years. We went through an iteration of accountability where we're taking verbal locations of where firefighters are on what floor, but that kind of changes, and during an unusual event, it can have a dramatic effect of where they are at that moment when they actually get injured. So 47 years for me.
Okay. Well, we're pleased to be able to start delivering on that vision that you've had for that long, you and all of the other first responders out there. All right, I'm not seeing any other questions right now, so I'd like to move on to Chris Gates here real quick. Just the slide. So he's going to talk about how NextNav is making vertical location a reality. And just to introduce Chris real quick, Chris is the Senior Vice President of Corporate Development and Strategy here at NextNav, where he heads our business development team, manages our corporate partnerships, and contributes to policy outreach efforts. Chris has lived and breathed vertical location for many years now. I consider him sort of an encyclopedia about all of this kind of stuff. And he really just has a holistic view of how the technology, the surrounding ecosystem, and all the regulatory frameworks all kind of come together. So he's going to give us a quick overview of how NextNav is bringing this vertical location to life. Chris?
Thanks, Ben. Why don't we skip forward to this first chart here, which highlights the key elements of our system. NextNav has been working on developing technologies, including vertical location technologies, to enhance location for first responders and for other applications for more than 10 years now, and we're really excited to be bringing this into the market today. We think it's an extremely powerful technology that, as I think as Chief Werner highlighted, can go a long way towards improving operational outcomes in the first responder community. And it's available without a lot of specialized hardware. So we designed our system for the most part to be compatible with most mobile devices that are in the market today, whether used by consumers or first responders or by other groups. And what we rely on is, in part, the presence of a pressure sensor that's available in most smartphones that are shipping right now, and actually have been for the past 5 years or so. These are very accurate measurement devices that are present in smartphones that allow us, when combined with other information, to determine very accurately the altitude of a mobile device. But what makes these usable really is, and kind of the secret sauce, is our network. We're deploying a wide area network to cover top metros in the United States and potentially internationally over time, based on very, very accurate sensing equipment that we place in these major markets around the country. It's a network that we designed and created ourselves to allow us to measure the variables that go into determining altitude using the sensors that are in mobile phones. And essentially what we do is load this information into our cloud services platform, and it's a real-time system. So we have a real-time perspective on all the variables that go into determining altitude. And when the device running our software through an application interacts with our cloud services platform, it has access to all that reference information. And that allows it to generate a very precise altitude. Now you might say, well, if these pressure sensors in these phones are great, then why can't you just do altitude all by yourself? And let's go to the next chart, and we'll characterize why that's the case. The main reason is that the weather is changing constantly, and by significant amounts from an altitude point of view. We'll get into the accuracy of our system in a moment, but essentially it's altitude at human scale. In other words, sufficiently precise to determine separation between floor levels in a multi-level, like a high-rise structure. Even in a calm weather day, you can see immense implied altitude changes based on pressure fronts moving through a given geographic area. And they move quickly over the course of minutes, in some cases even more rapidly than that. And over the course of hours, you can see implied altitude changes of hundreds and hundreds of feet if you weren't aware of what was going on. And in fact, these changes also occur over space. In other words, the variables that you're interested in for altitude determination at one location don't apply at another location, even one that's maybe even a few miles away, fairly close by. It's totally different. And so if you're trying to provide very reliable, very accurate altitude information, then you need a dedicated system for that. And of course, if you're providing service to the public safety community, the system has to be reliable. You can't depend on a system that you don't control. So we have the software on the mobile device, but then we also have the network that we manage specifically for high availability for public safety applications and safety of life type applications. So we go to the next chart. Our system's been tested significantly. In fact, in addition to safety for first responders, we're also pretty interested in the safety of citizens. And we've been working as part of the 911 process that's mandated vertical location to be delivered to smartphones in 2021. And our system has been rigorously tested in that context. And the net result of that is that for 80% of fixes in the most recent CTIA testing that was conducted using our system in 2018, we delivered about 6 foot accuracy or better, and for 95% of fixes, 10 feet accuracy or better, or about 3 meters for about 95% of fixes. And this was blind testing. It was conducted over tens and tens of thousands of simulated 911 calls using off-the-shelf devices running our software. So essentially, we shipped software to CTIA, and the Wireless Carrier Association. They engaged a test group. And then they went into different buildings in multiple markets, San Francisco and Atlanta, in a variety of conditions, and tested the accuracy of the system against a surveyed ground truth. And this is essentially what we came up with. So this is a very, very accurate system. That sort of 6 to 10 foot level that I was talking about certainly is about the height of the floors in most multi-level buildings in the US. If we go to the next chart. So we're launching this service. I mentioned the fact that this is a network-based service. We're actually deploying our own network infrastructure across 105 major US markets. And we'll be live in all 105 of those markets before April of 2021. We're actually live. I think we issued a press release last week in more than 50 markets today, and are well on our way towards meeting that 100 market milestone by next year. That'll ultimately represent about 85% of the 3-story or taller commercial properties in the US, and of course all the other structures that are within our network footprint. These are vast footprints. For example, in the New York metro area, which extends from Long Island all the way over into New Jersey, we're covering about 99.9% of the 3-story or taller structures there. If we go to our next, chart. So it doesn't. I think this is one of really the most important features of our system and our approach to delivering services. Obviously, wide area availability is critical for first responders. You can't plan in advance where some event is going to occur, or where an incident is going to occur. So you need to provide market-wide coverage. But if you want to provide a service that's practical for people to access, it also has to be available in devices. And I referenced earlier that our Pinnacle service doesn't require new hardware and devices. Most smartphone shipping today, including the ruggedized devices you see depicted here, incorporate accurate pressure sensors that are compatible with our system. And so what that means is, for an application developer, is that you're doing little more than integrating an SDK to deliver vertical along with the other functionality of your application, and presenting that to the end user or to incident commanders according to how your application works. So that's our system in a nutshell. And Ben, I don't know if we're going to get into Deepak's description of some of the software and how tactically to integrate this from here.
Yeah, we will. We do have one question from the audience, actually. How does the NextNav service differ from Rapid SOS?
It's a great question. Rapid SOS is a mechanism to provide 911 location information to PSAPs on an expedited basis. When you call 911, for the carrier to connect your call to 911, a sequence of events happens. And what Rapid SOS does is when you call 911, they essentially, in parallel with the carrier 911 call and location delivery mechanism, samples the location from the device and ships it directly to the PSAP without having to go through the full call completion program. And essentially that means that the location from the device can be delivered to the PSAP more rapidly. So that's Rapid SOS. It's instantiated when you dial 911, and it's a parallel service to the 911 call completion or text completion that the wireless carriers provide. What we're offering is a mobile application service, so that when you are running a mobile application that features our SDK, you can get very accurate altitude information on your device, including up to real time. In fact, we offer up to 1 hertz or once per second updates to end users, which is, from an altitude point of view, rapid. That's essentially real time tracking. So it's a very different use case when you think about it from that point of view. Now, of course, it's possible to integrate our service into a 911 call flow. We're a wireless carrier to adopt our service for 911. Then those same processes that allow us to deliver a z-axis or altitude to a mobile application could also be delivered to the wireless carrier for 911 services. So Rapid SOS in that scenario, of course, would be running in parallel to us, but isn't part of either the 911 call flow or the application flow that we're talking about today.
And maybe to add, I'd say Rapid SOS is more of a location transfer mechanism, whereas NextNav's Pinnacle service actually generates the altitude data in this case. So we actually use our network and service to natively generate the altitude information, which can then
that's an excellent way to depict it, Deepak.
And that's an excellent segue also into our next section, which is how to integrate vertical location into public safety apps. So let me just quickly introduce Buck, who's our VP of product here at NextNav. He leads our product team and has been hard at work putting all the technological elements of vertical location together. He's going to give us a deeper dive into how developers in the public safety space can actually integrate vertical location into their applications and services. So Deepak, take it away.
Awesome. Thanks, Ben, and welcome everyone to our webinar here. And to kind of build on how Chief Werner and Chris have said, both the utility of Z and how NextNav is bringing Z to the marketplace, we'll kind of dive into the specifics of how to actually integrate this into existing, let's say, platforms. Broadly, the way we think about it is we want to obviously make our Z data or the Z location information available in as many platforms as possible. And one of our biggest guiding principles is, because this is a key, let's say, dimension to location, we want to make it as simple as possible for partners to integrate this into platforms that they may have. And with that in view, we of course have a wide methods by which the service can be accessed. And how Chris was mentioning earlier, a lot of our initial focus, of course, is on the mobile side. Today, we do have mobile SDKs available on Android and iOS, obviously the two most popular mobile platforms. We're working on some of the other mobile platforms as well, but there we deliver our service through an SDK where app partners and app publishers are able to integrate this SDK into their applications that can now take advantage of a more precise altitude location data within their applications. In addition to that, we're also offering a Unity plugin. This is for the game universe, the app publishers that are building games using the Unity platform for various kinds of both gameplays, AR, VR type applications, things that can very eminently, of course, take advantage of precise geo-referenced vertical information. So we have another delivery mechanism. And looking to kind of the 2021 timeframe, we're also offering an API-based method for us for partners to access vertical location information, and this is really to enable a range of IoT or other platforms that are not covered by Android, iOS, or Unity at the moment. So that's kind of our the way of us delivering the service for partners to take advantage of. Maybe Ben, we can go to the next one. Right. So I guess I'm going to dwell a little bit more into the specific mobile SDK and kind of what that entails and how to integrate the Pinnacle mobile SDK in order to access the altitude information. We, of course, as I was saying earlier, pay a lot of attention to think about developers and how to simplify adding this information into their applications, because we obviously realize application vendors are already delivering apps in the marketplace. They have a range of competing needs. So we want to make it as simple as possible for them to do this and to reduce, let's say, time to market from their perspective of adding altitude into their applications. The SDK itself generates altitude in a couple of different formats, and we'll kind of get into that. The two most common ones that we provide today is the HAE and HAT, and we'll get into those specifics in subsequent slides. In addition to, let's say, generating the altitude, because we spend a lot of time thinking about altitude, and in general, because today, as Chief Werner was also mentioning, the world in general has been a flat 2D world, especially as information is represented on mobile or web or other kinds of platforms. We are enabling ability for partners to visualize the altitude information within their applications in a more, again, user-friendly or developer-friendly manner. So we've done some, put some thought into how to visualize it, and we're making those features available for developers so they can take advantage of it. And in general, as Chris mentioned earlier, the way our SDK works is, for the most part, the minimum information that we need is obviously pressure, because our altitude system is pressure-based from the device, as well as location, because obviously altitude is tied to a particular location. And those are kind of the two minimum information that we need. And of course, we combine it with our NextNav's altitude network that we've installed nationwide to then generate this precise altitude information. So I think we'll kind of go into the subsequent slides that build on each of these themes to kind of give you guys a more deeper view of how, or at least a high level, how the SDK functions. Maybe, Ben, we could go to the next one. All right. So the way we think about this in terms of making it easy for developers to integrate from an SDK standpoint, we have two modes of operation within the SDK. One we call delegated, the other is the direct control. In the delegated mode, we make it as simple as dropping in the library within the app, and of course there's a key that is needed in order to access the service, but the host app can ask the SDK to provide altitude data in one of four modes, like a one-time, or generate altitude once per second, or once per 30 seconds, or once per minute. So this actually, let's say, allows the host app to kind of delegate the whole altitude generation process to the SDK, and just worry about the output of the altitude that is provided by the SDK, and use it within the host app, so they don't have to worry about accessing the pressure sensor or accessing location or other kinds of information. The SDK takes over from this point and has actually collects the data, which is really location and pressure, but also connects up to our cloud service to download assistance information. Like how Chris was mentioning earlier, we have a real-time view of how, for any localized environment, how the surrounding weather is doing, so that we can calibrate out or factor out the surrounding weather in order to generate the precise pressure. So all of that background activity is taken care of by the SDK, and the SDK also generates the altitude locally on the device and produces that output for the host app to use at the rate that the app is specified. So that's kind of for those developers that want, let's say, a more baked solution where they want to delegate all of this to the SDK. So that's we support that. On the other hand, if there are developers that want to more directly control how the SDK should work, we also have the method where the host app can call the SDK in modes at rates at which the host app wants, if it's once every 5 minutes or one time, or however they want to do, so they can implement the timer logic, so to speak, as well as partners can implement the ability to push location data, especially in cases where they may be enhancing the fidelity of the 2D location or for other purposes. So we kind of have the two modes. We've actually supported partners to integrate our SDK in both modes. Both of them work quite well, and it's pretty straightforward to do. The other thing that our SDK does in band is, as you may all know, one of the key sources of error that prevent us from getting precise altitude is the sensors drift, the sensor within the device, the mobile device, whether it's a iPhone or an Android phone or any device. Really, these sensors have a certain drift characteristic through the life of the device or the life of the sensor on the device, and that drift is actually unique to a sensor. So there is a need to calibrate out the drift of the sensor. The Pinnacle SDK that we have actually takes care of that as well. Again, in a delegated or a background mode, so we do that. But there are some use cases that may require even higher accuracy. So there too, from an SDK standpoint, we have enabled a method for host apps to also request or have their users in an optional manner to participate in further calibrating the sensor on the device in order to achieve kind of the highest level of accuracy if needed. So we've kind of, the SDK also does, in addition to generating the altitude information, also kind of takes care of managing the sensor on the device to make sure that it can perform and deliver altitude to the highest level of accuracy that we can enable through our system. So in terms of the output itself, the SDK, as I was saying earlier, does output data in two formats today, which is the height above ellipsoid and height above terrain. The height above ellipsoid, as many of you may know, ellipsoid is a mathematical model that smooths out let's say the undulation of Earth, and so it's kind of a smooth surface, and the numeric metric system that we follow is the WGS84 datum. So that is a data that we output from the SDK. But also what we've heard from partners is the more, let's say, useful or human relatable number is, of course, the meters in HAT format, which is really the height of terrain. So in this case, we are converting the HAE height into a height that is, of course, tied to the device's location at any given time. So when the SDK gets the 2D location or reads the 2D location from the phone, it is generating a height above terrain value relative to the terrain at which the device is located, and of course based on the altitude generated by the device. And in many cases, and in all cases actually, both the HAE and HAT data that we provide, the height information, also comes with an uncertainty number. Many of you may already be aware, like on the 2D system, whether it's GPS or on any of the mobile platforms, the 2D location comes with an associated uncertainty. So it's a very similar concept. It's essentially the range within which the altitude value can lie, and with 90% confidence in our case. And this is kind of a heuristic based on how we have designed the system, the sources of error, and kind of how we manage and monitor our entire solution. So in addition to that, of course, our SDK has lots of other inputs, as you can see kind of in the right. There are status codes, that tell you about how the service is working. There are error codes, of course, in case things aren't working well. And there are a couple of inputs here that you can see there in terms of floor number and address. These are roadmap features. These are things that we'll come to at a later point. At the moment, not populated, but still available from an SDK standpoint. If you are accessing our system today and you're building an application, really the two altitude outputs you're really using are the height in the ellipsoid format, or height in the terrain, height above terrain information, and the associated uncertainty. So that's kind of the SDK's altitude output capability. The SDK, in addition to that, now that we have delivered the altitude, as I was alluding to earlier, there is, of course, a challenge of how to represent this altitude information visually to the end users. For those applications that altitude needs to be visually represented, of course, there's a class of applications where just the data is sufficient, the altitude data is sufficient to do different use cases. But in this scenario, if there are, for those class of applications where altitude needs to be visualized, we've spent some time and thought about this. What we wanted to do is we wanted to ensure that the app publisher is able to leverage their existing work, and in many cases, the app publishers are probably already visualizing the 2D location on a 2D map through our existing, popular 2D map vendors. What we've done is we've created through the SDK a mechanism to represent altitude on a 2D map. So it's kind of a 2.5D representation, if you will. And we kind of call this the altimeter. That's the sidebar view. So the SDK, through a function call, can draw this altimeter bar that Ben's highlighting up here. And in that altimeter bar, the SDK also has functions that the host app can feed in the height information, and of course any markers in terms of icons or other kinds of indicator about to which user or device that height belongs, and they can pass it in through a function. and that actually draws it and represents it in this altimeter view. So you kind of have in a 2D map that the app publisher is already using this overlay that allows you to visualize in terms of relative position, where the different users are depending on their use case. It could be applicable just for a single user looking at their own position relative to ground where they're at, or in the case where the use case requires for app publishers where there are pulling in multiple, especially for situation awareness type apps, where they're bringing in multiple 3D location information from different users. They're able to stack this up as shown here. And we have some other functionality built into this altimeter view in terms of providing more detail and also characterizing the blue bar that you see up here shows kind of the uncertainty range of the altitude that comes up here. So there's a few different areas that or functions that we have within the altimeter, all toward an eye of providing almost a running start to our app publishers to help visualize this altitude information. So this is an option that's available in the SDK as well. So a little bit more, let's say, detail in terms of what the SDK is. Of course, we have an Android version and an iOS version. The SDK sizes are pretty small. On the Android side, it's 1 MB. It's actually a little less than that. On the iOS side, a bit larger at 5 MB. And what we provide as part of a developer package is, of course, the library files. There's a developer guide that goes with it, but also we provide a test app that includes these library files. There's an Android test app and an iOS test app to show our partners, how the SDK is integrated, as well as they could, take it for a test drive and look at and experience the technology as well, even as they're integrating the SDK into their own applications. And of course, we welcome you to send us an email at partnerships@nextnav.com to get access to the developer key, because obviously you need to put in the key in order to be able to use the libraries within your applications. So we certainly welcome you to send us a note to get started on this. Maybe we can, so I think that was.
Okay. Thanks, Deepak. We've actually got a couple of questions for you. First of all, will we be providing the weather sensor data in the form of an API?
I'm guessing the question probably relates to the reference data. I'm guessing. So at the moment, our mechanism in order to deliver the service, the Z service, is not to actually deliver the weather sensor or the reference network sensor data directly, but really through the generation of altitude by the use of our SDK in this context. But there are other contexts that we can certainly explore, further. I think I'd encourage whoever asked that question to reach out to Chris to kind of explore those options.
And another question, how is building data acquired? So in other words, floor level data, if you know it in the building.
So that's a good question. So in this context of the Pinnacle service at the moment and with the SDK, what the SDK generates is really the height in this height above terrain or height above ellipsoid information. And for the most part, it's the app publisher that's looking at how they render it, whether they want to place that on a building or how the building model is done. There are, of course, a range of data vendors that provide building information, and of course, different app publishers have different preferences in terms of their data sources. So we, at least in this context, would imagine in this time frame that the output of the SDK is the location data, and then outside of the altimeter feature that we provide to visualize data, if a app publisher wants to visualize this within a building, that they would go and acquire some of this building information, of their own using their partnership network.
Okay. And then one more that I already answered, but you can add any additional color if you like. Will you have local pressure sensors throughout each of the 105 cities? And the answer is yes, but do you want to add any other color to that?
Yes.
Let me answer that. So we're deploying altitude stations that deal with a variety of different factors, and we are deploying them throughout all 105 markets, not cities, by the way. So if you kind of think about individual municipalities, it's probably hundreds. I don't think we've done a detailed count, but it's 105. What we call a market is a metropolitan statistical area, so fairly broad areas covered that way with our network footprint where we deploy our altitude stations.
Deepak, what advice would you give to developers who are just starting off with vertical location? Is there anything they should keep in mind as they start to work with this new capability?
Yes, certainly. I mean, at least from the Pinnacle service standpoint, I would say integrating the SDK we've made it as simple as possible. I would almost say it's a trivial activity to integrate the SDK within an app in order to access the high precise or high performance Z data. What I would encourage app publishers to think about certainly is how to visually represent the altitude information that is meaningful to their use case. And of course, there too, we've made at least our attempt at making it also easy for app publishers to represent that information through this altimeter feature. But that certainly, of course, is an option. Obviously, the app publishers are the best judge of how they would need to use or represent that information. But I would say primarily because we all as users, for the most part, have been tied to looking at this on a 2D plane, essentially plotting the lat long on any of our maps. Representing altitude definitely comes with certain challenges in terms of kind of the UI and UX in terms of how you would actually represent the information. We've of course taken a stab at it with our visualization recommendation and technique, but that would be an area I would say publishers would want to spend. I'm sure that's what they're doing, spending most of their time thinking about how to represent the information to their end users.
And I'd like to add, I think that from a public safety perspective, just as kind of a visual, is that if we can differentiate fire by red, EMS by yellow, police by blue, it gives us a really quick way to see which responders are in which locations and what discipline they're from, just as a concept.
Yeah.
And then Deepak, finally, if you're a developer on this call and you're looking to get started, you think, hey, this is a great opportunity, this is a great capability, I want to add it to my application. How do you get started?
Yeah, I'd say at this moment, as Chris was saying, because we're rolling out the nationwide network, really, folks in any of these 100 markets where we have service obviously have the front row seat in terms of developing applications, because the network is up. You can actually experience the service firsthand in real terms and also check it out. So I'd say we'd certainly welcome all app publishers and partners to send us a note at partnerships@nextnav.com. What we do is we obviously write back to you with both the key as well as the developer package. As I was highlighting before, this would include the library, the developer guide, as well as the sample application. So we, of course, want to proliferate our service and technology in as many app platforms. So we are ready and eager to let's say engage app publishers. And I would say, I guess I'm coming across as harping on this point, but we've really spent a fair bit of time thinking about how to make it as simple and easy for publishers to integrate this technology and solution. So I think once you start to look more deeply into our developer guide, I think you'll come away with the same. And we've had partners who have actually integrated the SDK in like a day, where they've just dropped this in and put in the key and been able to access the altitude information. So I think certainly the integration part is going to be smooth, but like we touched upon before, Ben, the visualization and how to represent the information, of course, they would already, the publisher partners would have their views of how to represent this. So that's where they'd have to spend some time.
And if I could add to this, I'd just like to say to developers, if you ever wanted to get involved with a project that could save lives, this is it.
That's a great way to end it, actually. I mean, you can't get any better than that, right? If you want to save lives, integrate this technology. So Charles, Chris, Deepak, thank you so much for joining us today. We're going to make this recording available in just a couple minutes. And thanks everybody for attending, and we'll look forward to speaking with you in the future. Thanks again.